Welcome to part 14, JavaScript in the backend. Now, JavaScript, as we have seen and as we have done for parts 1 through 13, runs in the browser very well because browsers have a JavaScript engine. However, to run JavaScript on a backend server, a server which you host yourself, you will need a JavaScript engine. The most common JavaScript platform or engine is Node.js. It's actually Node.js. But there are others like Dino and Bun, which are also JavaScript engines. Just like the browser has web APIs, such as getElementById or the fetch element you saw, each engine or platform has their own set of supporting libraries and APIs. However, as Node.js is the most established, both the Dino ecosystem and the Bun ecosystems, which are the new JavaScript engines or JavaScript platforms, they strive to be compatible with Node.js. The compatibility is good, but there will be differences, and sometimes the corner cases will rub you the wrong way. So what are the pros and cons of using JavaScript in the back end? Well, if you write JavaScript in the front end and you already know JavaScript, you can use it in the back end. So that's a major pro. You don't have to learn a different language. Furthermore, with Node.js, Dino, and Bun, many of the web API classes, like request, response, fetch, are supported. They are almost identical, actually are identical. And JavaScript engines are fast and excel at I/O or input and output bound tasks. So what are the disadvantages? The disadvantages are mainly that JavaScript is single-threaded. It can only do one thing at a time, which is why you never block the main loop. And it performs poorly with compute-intensive tasks because it takes time to compute things and it blocks the main loop. Secondly, JavaScript is dynamically typed. So if you say let a equals 2, which is a number, and a equals TWO, which is a string, it will not cause an error. It will just run. This is why TypeScript was invented to address this issue. There's a TypeScript checker which checks before you run the erroneous code. There are many other languages, computer languages like Rust. It's all the rage these days. It features no garbage collection and it's memory safe. Or Go, which is very strongly typed, has excellent shared memory concurrency. The TypeScript tooling is actually being coded in Go as we speak, and it's often much faster than JavaScript. I choose Dino and not Node.js because it has native support for both JavaScript and TypeScript without any add-ons. And by the way, Dino was written by the same person that wrote Node.js. So let's test this out. We have an LLM that streams responses slowly. And this is my main JavaScript file. We import serve directory from this thing called standard HTTP file server. This is a Dino library, but it is from Dino's JavaScript repository, JSR. This is my own function. I wrote a dflt.js file, default.js, and it only has one function which is exported. It's environment string. It actually defaults, actually gets a value from the environment. But actually, let's go through. That's our main function. I like to have a main function in JavaScript. It's not needed, but I know where the main entry point is. Again, this is the definition, and this is the execution of the main function. Main handler actually is a function, but I decided to declare it this way as a constant because I'm not going to change my main handler. As a function that takes a request and returns these things. What does it return? Well, it returns it takes in the request. We look at the URL and we look at path name and we extract the path. If the path starts with /md, we run the md handler. If not, we serve, this is a regular static file server. So my HTML is in a subfolder HTML. And we're not going to strip anything in there's no URL base, if you like. This is where I use environment string. It looks for the port or port environment variable. If it cannot find it, it defaults to port 8080. So you can say port equals to 8081 and you will run it on localhost port 8081. But not only on localhost, it actually opens up to the entire internet. And this is a Dino specific again. Dino serve, it makes use of the built-in HTTP server on this particular port with the main handler, which is this function over here. So let's look at the JavaScript repository. The imports look familiar, but what's all this standard HT? It's defined in dino.json, which is very similar to Node.js's package.json. So this is an imports map. If you see this string, standard HTTP, replace it with standard HTTP at this semantic version, at this version 1.013. This is very useful to create stable, repeatable builds. And DFLT is my dflt.js file in the same folder. So let's look at it. By the way, Dino requires you to specifically allow network access, allow environment access, allow read access to the local file system. My code is in main.js. I didn't copy that. Okay, let's run it. So Dino is now running on port 8080. Let's look at it. Do a full refresh. And there we have it. Dino is streaming. By the end it streams. Let's look at the console, which I have. Let's run that again in the console and look at the console. So favicon, again, ignore. Defines the markdown handler. The markdown handler is starting. It hasn't completed. Now it's completed. If we look at the network, we see quite an interesting network graph. Let's clear that. Reload. That's the streaming. Now, this streaming took 8 seconds to complete, even though the initial DOM was loaded in 71 milliseconds. 8 seconds is an extremely long time, but because of this technique, it actually feels okay. So what's the difference between Dino and Node.js? If you look into default.js, default.js uses a Dino-specific Dino environment get environment variable. In Node.js, we have process environment variable. So as I mentioned, they strive for compatibility, but there are differences. Let's look at the markdown handler. The markdown handler has a lot of quick brown box text, which I didn't show. But if the path is /md, it runs the markdown handler. So that's the markdown handler. It's some headers, transfer encoding, as we saw in Go. And we have this thing called, we have a new response with headers, but slow response interrupted at 150 millisecond intervals. So let's look at it. By the way, request and response are your standard web API requests and responses respectively. So slow stream, we use a library from Dino, the standard JavaScript repository, standard async. We split it up, we create a new text encoder. We have a new readable stream. Readable stream is a web API again, it's not Dino. And readable stream has start, cancel, and pull. Pull pulls in new content when the buffer has space. So we look at the word, which actually is the array which is split up. We reinsert that space because we stripped it out in the top. If it is equal to the part's length, we use the stream control. We have this variable called stream control. You can call it anything. The documentation lists it as controller, but I like to use stream control. We close the stream and we get out of the pull, asynchronous pull method. If we still have stuff to go and not at the end, we enqueue. After encoding it to UTF-8 text, we await for the delay, which is 150 milliseconds in this case. And then we increment the pointer to see whether we have come to the end. And we return this readable stream. So if we look closely, we close the stream. I mentioned that already. We enqueue the words. We wait for the delay. Now, we don't have to write backends in JavaScript. I actually prefer to write it in Go. So let's compare it with the Go function we have seen. This, I feel, looks cleaner, easier to understand, and it actually runs faster as well, just slightly faster. But if you've got compute-intensive stuff, then Go is better, and it's strongly typed. That brings us to the end of my additional content. As usual, the code and all the presentation slides are available on this GitHub repository. Thank you.